All right, so what we're going to do in this video is we're going to talk about the different set identities that we have. All right, so the first one, let's go ahead and let's use the Venn diagram to color in everything in our universe. So everything in our universe, this rectangle represents our universe. So if we want to color in everything in our universe, we would just have to shade in everything in this, including the set A, including everything else that would be in here as well, because everything within our universe is every single piece inside of here. So if we were to go ahead and solve for our universe coloring in our Venn diagram, we would literally color in everything else. Now, or everything, not everything else, is everything. Now, if we wanted to do color in our Venn diagram for this, A union A complement, well, first we would have to color in everything within A, because they're telling us everything's part of A. And then since it's union, it means it's or. It could be both. So it doesn't have to be both at the same time. It's just one or the other. So first we would color in this A, but then everything in A complement is everything outside of the set. So it would be everything out here as well. So we would color in everything here. So what do you notice about these two colorings then? These two produce the exact same Venn diagram. So we can then go ahead and say that if we're given the universe, that this set is actually equal to our A union A complement, that these two are equal to each other. We can actually rewrite this or replace them with one another, or we just know that these two have the exact same Venn diagram when we go to color this in. All right, there's a few other set identities that we're going to talk about as well. All right, so the next one we're going to talk about is if we're asked to fill in for the Venn diagram, A union B complement. So that means we're doing to complement to both A union B. So since we know A union B includes everything within the set, within either of those two sets, because we're using the word or, if we're taking its complement, that means we're doing everything on the outside. All right, so we can color in all this in out here. And then the next one we're going to discuss then is A complement and intersection B complement. So if we were to go ahead and do A complement, so I'm going to do this one in two steps. A complement, that would be everything on the outside here that I'm coloring in yellow. It's everything outside that set A. If we were to go ahead and do B complement, that would be everything outside of this set B. So then since we're looking for A complement and B complement, we're looking for where they intersect, so where they share, we would then include everything, let me do it in purple, everything outside of both of these circles A and B, because here, this yellow inside our set B, it's not included with the blue. So here there's no blue, here there's no yellow. So the only parts that have both are everything on the outside here. So we can then say, if you look, we can then say that these two are in fact equal to each other. So we can say that A union B complement is equal to A complement intersection B complement. All right, they are in fact equal to each other. All right, so the next one, if we were to go ahead and do, let's say we're going to shade in the empty set, well, that means that there is no elements in here at all. So we won't shade in anything. We can't even shade in the universe because although the empty set will be part of that set, there's nothing for us to shade in because there's nothing colored. So then if we go ahead and try and do A intersection A complement, well, first let's color in our A. So our A will do in yellow. So here is our set A. And then let's go ahead and do our complement of A in blue. So that's everything outside of blue. Or I'm sorry, outside of the set A. So it's all this blue here. Well, there's nothing that they overlap. There's nothing that they share. And this intersection means that they have to share. So that means that here, when we go ahead and do this, there's nothing that we can color in because there's nothing that they share. So we can go ahead and say that the empty set is equal to A intersection A complement. Now, we probably should have done this without B if we were going to do this, but I had two circles drawn in a Venn diagram, so just was doing it with this one. But we probably should have done this with just one circle in the Venn diagram. All right, there's one more set identity that we need to go through. All right, so the last one that we need to go through, if we're given the A intersection B and we're asked to do the complement of this, sorry, let me use the correct one that our book uses, and we're asked to use the complement of this. Well, first we need to solve for what A intersection B is. And A intersection B is this part here. So if we want to do the complement of that, we need to go ahead and color in everything that's on the outside of this. So this would all be our A intersection B complement, all of the purple or pink that I'm doing now. All right? Now the next one we're going to do is A complement union B complement. So first I'm going to color this in with yellow, and I'll do the A complement first. So here's the A complement. All of the yellow. And then next I'll do the blue, I'll do for B complement. So here's the B complement, all outside of our B. Whoops. Our B complement, sorry, all outside of our B. So it'll be here, everything outside of our B. And now we're doing union, so it's one or the other. So it means that it doesn't really matter as long as it has a blue or as long as it has a yellow, it works as an answer. So everything outside of this intersection was colored in. So this is the exact same shading that we would have for the one that we just did where it's A intersection B complement. So these two are equivalent, they're equal to each other. So we can go ahead and say that A complement union B complement is equal to A intersection B complement, that they're equal to each other. All right, so there's this 4 identities that we just talked about, and let's just go ahead and list these one more time. So the 4 that we discussed is we said that, hold on one second. So the 4 that we discussed is we said that A union A complement is equal to our empty set, and that just makes sense because it's impossible for us to have same elements in our complement of A as in our set A. So it's just an empty set. We have that A union B complement is the same or equal to A complement intersection B complement. We have A intersection A complement is also equal to the empty set. I'm sorry, this was a mistake. This is not the empty set. A union A complement, that means it's one or the other. This is supposed to be our universe. A intersection A complement was the empty set. Sorry about that. And then the last one is A intersect B complement is the same thing as A complement union B complement. All right, so they are the 4 set identities that we have needed to learn in this section, and then you will use these when you're answering some of your questions. And that is it for this video, and that's it for this section.